Hello, good morning everyone, and good afternoon, depending on your location. Welcome to this webinar. My name is Floris van den Hoeven. I'm based in the Netherlands, in Carlson EMEA office. And we will be doing a series of short webinars. So we aim to do it all within 20 to 30 minutes. So everyone can attend without losing too much of their time during the day. So we'll be talking today a little bit about point deviations and alignment reports. A lot of people are already familiar with using the Cutsheets within the Carlson software, but there's a lot under the hood that a lot of people are not using, I think, at this moment. So that's why we'll be doing a short presentation on that one. I'm sitting here together with my colleague Rob van Etten. He will be answering all the questions, or he will forward them to me. So if you have any questions, just type them in, and we will try to answer all of them. Excuse me. Okay, Cutsheets. I will be showing point deviations, which you can use for pile deviation reports and everything that has to do with deviations between just two coordinates. Also, I'll be showing a little bit for alignment deviations, so you can use that for roading applications, even a little bit of tunneling or sound barrier design, or so a lot of as-built stuff. Basically, you can do it the simple way, simple deviations, and that's what I will be showing, and also by using center lines to align the deviations. So the vectors will be aligned according to the center line. The main thing, because it's actually just a simple three-step process. We go to Cutsheets, you import your point set, and you do grade by points. That's all very simple to do, and that's why we can show this easily within the set time frame. Everyone, I think, has seen the default cut sheets, but of course what we will be aiming for is to show the vectors within the drawing as well. And therefore we go to Draw and check the label settings and do the Draw Delta symbol. Now of course there's some more settings you can do within that screen, setting layers, colors, and choosing the symbols, setting the tolerances, which I will quickly show as well. And the outcome will be, in this case, a simple deviation shown by vectors. Now let me show you in real life example. So here I have a typical piling design from one of the local job sites down here. So probably most of you are pretty much familiar with these types of drawings. So from this drawing, this panel is in the way, let me remove it a little bit. Okay. We made a simplified one, and this is basically my background where I want to report the deviations. So as you probably know, within the Survey tab, we have the Cutsheets option. Well, Cutsheets is much more than simple cut and fill sheets. There's a lot of power in there that yeah, you should all have a look at if you are not doing that already. So the first step, what we will do is import. I'm going to import my as-built points in this case. So it's a normal CRD file, as-built, and I'm going to open it, and of course you can define a selection set or a range or In this case, I always just say all. So these are my S-build points. Second step, it's very simple. I'm going to select points for this webinar. We can do a lot more. We can do deviations based on the triangulation file, polylines, grids, a lot of other stuff. But for today, we will just limit ourselves to points because of the time frame. Now for the design coordinates, it will ask you if it's in the current file or if there's another file. In my case, they're nicely grouped, so that it's in a separate file. Later on, I will show you how to do the same thing, but then from one file. So then the design and the S-build points are in one file. So here I choose the design, and I'm going to open it and do all. Now there's a couple of options. You can do match by distance, or you can do by points, or based on descriptions. But in this case, for the piles, I'm doing it by distance. And in my case, I'm in the metric system, so I do 0.4 meters. And depending on the design, you can set it, of course, a bit higher or a bit lower. But that depends on the spacing between the piles. So in this case I do 40, and you can see it's nicely matched all the points together from the two files. Now what a lot of people do within Carlson at this moment, they do report, generate a report, and just plot these tables alongside the drawing. Pretty boring actually. So let me show you something to make it more visual. So this was the third step. We go to draw and first go to the label settings. So we can set tolerance markers. So if we're outside of tolerance, you can select your own symbol and set the layers. Pretty straightforward. In this case, this is the interesting part, the delta labels. So we're going to enable draw delta symbol. The rest I will explain later. Do OK for now. And I say draw labels. And it says 7 points are marked because they were outside the set tolerance that we set in this drawing. So I said OK. Now I'm just going to close this window. And then you will see, no, because it's easy to redo. Oh, get me back my program. Okay. So now you can see within this drawing, all the vectors are drawn together with the values. This is already a nice result, but this is not the result we are aiming for. It's drawing this way because if you can see my north arrow, my grid is facing this direction. So normally the XY deltas are shown perpendicular or parallel to the grid that you're working in. This is not what we want to have, because we want to have some more feeling with the project. So I want to align all the vectors with the real structure. And of course then the deviation should change as well, because if I use a different reference, the values will be changing as well. So quickly going to remove what we currently have. Just isolate them. Nice feature, by the way. And put everything on back on again. So to align them, I can rotate my full drawing, of course, so it's north faced again, but that's not what I want. I'm going to create a quick center line. So I'm going to center line, design center line. Yeah, just overwrite that one. That's fine. Yeah. And I just say OK. So what I'm going to do is just basically make a reference line. And let's say the endpoint over there. Okay, and we'll be using that line as a reference. So then we're going to redo the steps. I could have saved it, but because of it's so easy to do, and it's good to just show it how easy it really is, I'm just going to repeat the steps again. So import points, grade based on points, and I choose the design coordinates. Do all, okay, got the match again. Now there's one thing I have to change. I'm going to draw label settings. And within label settings, there's rotate deltas by center line. Now, this is the one you need to enable. And then when we do draw labels, okay, then it's going to ask me to pick the center line. We save the center line, so I can now select it. It's showing it on the screen. I can say open it. I can close it. No, not going to save it. And now you can see, let me remove this one. Now you can see that it's nicely aligned with the work, and this gives you a nice visual presentation that you can easily print out and give to your site supervisor or the engineer or whoever is in charge of evaluating your as-built drawings. And of course you can still combine it with adding the XY plot on the right side or wherever you want to place it. So this is already a very powerful feature within the software. Of course you can set the amount of decimals you want to use. You can specify if you want it in metric, feet, inches or whatever. It's pretty straightforward. So you can tailor it exactly to your needs. So that was the part that we showed you here. So rotate deltas by center line. So it's nicely distributed now. But it's also, this was based on a straight line, but of course the center line can be curved. So if you have railroad or a road design, or you have, in this case on the picture, like a sound barrier, and you want to have all the deviations based on the center line, we can do that as well. So let me get back to how are we doing so far, Rob? Already a lot of questions, or?
No questions yet, so just keep going.
Good. So I'm going to open now. Let me open up a new drawing. So to keep it simple, just a simple center line from a side, and we're going to load the data in here. So we do the exact same thing. We're going to load the go to Survey, Cutsheets, import points, and in this case we do InterGeo barrier design. Okay, and now I say all, so it's around 1344 points. Okay, so in this case the points are mixed. These are the as-built points, but also the design points, which can happen a lot, of course, when you're loading in your design into Cersei or and start working it, and after stakeout measuring it in again in the same file. So this is a pretty common situation. in this case we didn't use descriptions, so I cannot in this case I cannot do matching based on descriptions and not on point numbers, because of course all the point numbers are different. So let me show you. We go to grade and points, and we say the source of the design coordinates are in the current coordinate file. So what I'm going to do, I'm going to match by distance. Just say all again. Match tolerance, keep that the same, 40 centimeters, and I say OK. And now you can see perfectly found all the points. Now before I start plotting this on the screen, I want to remove the second half, but because of course if both are in there, then it means you would get a match from survey to design and from design the other way around again. So I'm going to remove one group of the points because now they're double. Okay, deleting the points. Okay, there we are. Now, let me check the settings. Draw label settings. Draw deltas by center line is turned on. Draw delta symbols. The rest is all still okay. I say okay. So if I now do draw and draw labels, 0 points out of tolerance. That's the thing we want to hear. And of course I have to select the center line again, which was in this case in the middle of the screen. It was the center line. I say OK. And it will start plotting around 500 points along the center line. And I can close it. Save changes. No, don't want to save. It's too easy to redo. Now you can see all the deviations are nicely taken perpendicular to the center line of the project. So this is a better way of getting a feeling behind the numbers, because if you just plot values in a big table, you don't have any feeling with the values. But of course, in this way you can quickly see if they all have the deviations to the same side, or you can quickly determine what the cause is. Maybe with heavy machinery they drove too close to the stake, so then usually you would see them all going to the same direction. So pretty straightforward, and everyone can do this easily by themselves. It's no rocket science, but it greatly enhances your reporting and evaluation of the numbers. So this was basically the thing that we wanted to show during this short webinar. Let me see if I got everything. Yeah. So yeah, let me know if there's any questions. Rob, do you have any questions open in your screen that we should address?
Yeah, I have a couple of questions here. Are the arrows pointing towards design location or away? So a question about the orientation of the arrows.
And you can select that in the software. So let me go to survey, Cutsheets, great, draw label settings. Let me open up the other drawing again, so it's easy to see. Oh, come on. Let me get this webinar view out of the way. Nope. Well, it's a setting. You can select if you want to do as built compared to design or design compared to the as-built. So if I do survey Cutsheets import points, I do as-built, yep. And if I do grade points, another coordinate file, design, okay. Was it? I was in the report settings. Yeah. So here's the. You can select design to survey or survey to design. So you can select yourself which way you want, which direction you want to do it.
Okay, yeah, there's another question. How would you show 3D differences from design for structure? So maybe showing the complete 3D vector, I guess.
At this moment, the vectors are only drawn in 2D because it's based on 2D blocks and not 3D blocks. So we don't have 3D. We don't have the Z vector at this moment. We only report the X and Y vectors.
Okay, I don't see any more questions coming in right now. Of course, all questions can always be directed to the support mailbox, support@carlsonsoftware.com or support@carlsonemea.com. So, no more questions, Floris.
Oh, good. Then, that's good. That means it's simple. Before we leave, I wanted to point everyone's attention from the people who are coming from Europe that we will be having a Carlson EMEA user conference that will be held in Czech Republic at the 23rd and 24th of June. So hope to see you there. And Rob, thank you very much for your help today. And I would say to everyone, thank you for attending, and hopefully see you all soon in the next webinar. Thank you very much. Bye-bye.